Today we're starting Chapter 1, which is on equations and inequalities. And more specifically, we're going to look at sections 1.1 today, which is applying properties of real numbers. And our goal is to study what are the properties of real numbers. Well, if we look at real numbers, all real numbers can be split into two categories. Either they're rational or they're irrational. And then the rational numbers include the integers and the whole numbers. And when we talk about rational numbers can be written as follows. All rational numbers can be written as the ratio of integers. Essentially, it means we can write it as a fraction. If you have a number that's a fraction, automatically it's rational. Also, if it's written in decimal form, its decimal must terminate or end or repeat. Okay, so those are the two things that would make it rational. So as a decimal, it would either end or it would go in a repeating fashion. If it's a decimal that goes on forever without repeating, that would be irrational. So when we look at example 1, our goal is to graph these numbers on the number line. Well, for us to graph them, we have to remember that the bigger numbers are always to the right and the smaller numbers are always to the left, with, again, our positives to the right and our negatives to the left. So the first thing that I would recommend doing is putting these numbers into decimal form. It's just easier for us to see where they actually go. So 7/2 is 3.5, and the square root of 5 is 2.24, so this is approximately negative 2.24. So if we put these on our number line, we're going to put a dot representing the place on the number line. So this is the negative square root of 5, and here is 7/2. So when we graph these, the dot represents where they occur. And again, we want to write the numbers that we are graphing on there. So that's how you graph numbers on the number line. In example 2, we're talking about the standardized test practice. Says a table shows record low temperatures for several states. Which list shows the temperatures from highest to lowest? So we want those numbers from highest, so the highest degree, down to the lowest degree. So we have to look through and see which one of these it is. So obviously, if we look through these, we see that the highest to lowest is, in fact, C. All right, at this time, I would like you to take a couple minutes, and I want you to do questions 1 and questions 2. So number 1, they want you to graph the numbers on the number line. Number 2, they want you to show which list shows the numbers in increasing order. So what I would like you to do is pause the video while you do this, and then you may hit play when you are ready to resume. So here are the answers to questions 1 and 2. Next, we're going to jump down and talk about the properties of addition and multiplication. So in these, we're going to let A, B, and C be real numbers. The closure property just means if A plus B is a real number for addition, if A is a real number, B is a real number, then add them together, they're real. Same thing multiplication. If A is real, B is real. If we multiply them together, we're going to get a real number. Commutative. A plus B equals B plus A. We're just switching the order which we do that. Same thing with multiplication. A times B equals B times A. So commutative means we're going to switch the order which we do it. Associative. It's A plus B in parentheses plus C equals A plus and then B plus C in parentheses. And then the same thing for the multiplication. AB times C is equal to A times B times C. So notice in the associative property, we're not switching the order, we're switching the order in which we do them. So those are the two that most people get confused about. Remember, the commutative property, we're switching the order which they occur. The associative means we're switching the groupings. The identity for addition is A plus 0. So what number can you add to not change it? And that's 0. So A plus 0 equals A, or 0 plus A equals A. And then for multiplication, it's 1. A times 1 equals A, or 1 times A equals A. The inverse for addition is you're adding the opposite, so it's A plus the opposite of A equals 0. And for multiplication, it's the reciprocal. A times 1 over A equals 1. And again, A cannot be 0 in that case. So, and then we also have the distributive property, which we've seen many, many times. Here we have A times B plus C equals A times B plus A times C. So AB plus AC. So we're going to identify the properties of real numbers. So if we look at example 3, question A. Notice we have 5, 9, and 12, 5, 9, and 12. The order does not change, but the way that we group them does. So this is the associative property of addition. Okay, so that is the associative property of addition. Now, if we look at B, we're taking 250 times 1, and we get 250 as an answer. So we are looking at the identity property of multiplication. Now we're going to talk about a couple of definitions. And the first one's the definition of subtraction. And then we're also going to talk about the definition of division. The first one says subtraction is fine as adding the opposite. So it's adding the opposite. The opposite or additive inverse of any number B is negative B. And B is a positive, then negative B is negative. So B is a negative, then B is a positive. So for example, if we have 5, well, the opposite of 5 is negative 5. If we have negative 2, well, the opposite of negative 2 is positive 2. So that's all the definition is. It says you're going to add the opposite. So instead of A minus B, it's going to be A plus negative B. And division is defined as multiplying by its reciprocal. So the reciprocal or the multiplicative inverse of any non-zero number B is 1 over B. So the reciprocal of 5 would be 1/5. The reciprocal of 2/3 would be 3/2. So we just multiply by the reciprocal, or basically you flip your fraction. So in example 4, it says you're going to use the properties and definitions of operations to show that this statement is true. That 10 divided by C times C equals 10 times 1 over C times C. So in geometry, we did a lot of proofs. And we looked at proofs. So this is a type of a proof. We're just going to show this, how we get the left side to equal the right side. Well, and it's simply one problem. This is a definition of division right here. We have a division sign. Well, we want to change that to 10 times, instead of C, we're going to say 10 times 1 over C times C. Well, if we look at that, that's exactly what we have right here. So this is just by the definition of division. So we're going to jump down to the guided practice questions, 3, 4, 5, and 6. And I want you to go ahead and do those. Identify the property that the statement illustrates. So write down which property is being used in this case. So go ahead and pause the video, and then you can hit play when you are ready to resume. And there are the answers for questions 3 through 6. Now, if we jump to questions 7 and 8, it says use the properties and definitions of operations to show that the statement is true. Justify each step. Now, I'm going to go through steps for question 7 with you, and then I will give you a chance to do question 8 on your own. So let's start. We're going to take the left side of number 7. We're going to try to make it equal to 4. So the first thing we see here is there's a division. So we want to get rid of the division. We're going to switch that to a multiplication. So it's going to be B times and then in parentheses 4 times 1 over b. Okay, so that's what we have. So that's the definition of division. Then I'm going to end up, I want to multiply b times 1 over b, but I can't do that as is, so I have to switch this. So I switch the order in which I have my 4 and my 1 over b. Well, that is a commutative property. And I'm just going to abbreviate these. Commutative property of multiplication. Well, now what we're going to do, I want to put the b and the 1 over b together. So we're going to write it like that. Well, now we switch the grouping. Well, if we switch the grouping, that's the associative property. Well, if we take b times 1 over b now, that's going to be 1. And so when we do that, that is going to be the inverse of multiplication. And we all know that 1 times 4 is 4. And so that is the identity of multiplication. So now notice we started on the top left. We took this statement and we simplified it all the way down until we got to here, which is what we wanted there. So that is how you use the properties and definition of operations to show that the statement is true. So what I would like you to do now is take question number 8, and I want you to do the same type of thing. We want this on the left-hand side to end up equaling that. So write step by step what you have to do and follow the same type of thing that we did here. It won't be as many steps to do for question 8. So go ahead and try that one. You can pause the video and hit play when you're ready to resume. Then there's the answer for question number 8. Notice we use the commutative property, then the associative property, and then simply 3x plus 4x is basically combining like terms, so we have that. The next thing we're going to talk about is something called dimension analysis or unit analysis. Your science teachers might call it one thing or another, but either way, you have to know how to do this, how to convert things from one type of unit into another type of unit. So unit analysis is when you use operations in real life problems, you should use unit analysis to check the units in your calculations make sense. For example, I can't tell you how many times that I ask questions in class, and like if we're dropping a water balloon from the top of a building, somebody tells me it takes 2 hours for that balloon to hit the ground. We need to make sure that all of your answers make sense. So in example 5, we're going to use unit analysis with operations to figure these out. So A says you work 8 hours and earn $60 an hour. What is your earning rate? So how much money do you make per hour? And so that's 60 over 8 hours. So the money per hour, so and we all know how to calculate this. You're just going to divide these two. And that's going to give you 7.5 over 1, which is $7.50 per hour. Now this is something that definitely all of you have done before. Well, how much are we going to make per hour? Okay. The next thing we're going to talk about is kilometers. And they tell us we're going to go 90 kilometers per hour, so that's in 1 hour. And we want to calculate it so we get into meters per second. So our goal over here is to make it look like meters per second. So what we want to do is change these so that we can end up with those units. Here we have kilometers. We want to get to meters. On the bottom we have hours. We want to get to seconds. So we're going to start with one of the units. Okay, so let's start with kilometers. Well, I know I need to get to meters. So here's how we do this. If I have kilometers on the top, I'm going to put kilometers on the bottom. Because if I have 5 divided by 5, that's 1. 7 divided by 7 is 1. 0.5 divided by 0.5 is 1. If you take anything and divide it by itself, it is 1. So if I have kilometers in the numerator, I have to put kilometers in the denominator because they will cancel out. That's our goal. Now, I want to get to meters, so I'm going to put meters in the top. So now the way we're going to look at this is which one is bigger, a kilometer or a meter? And that's a kilometer. So we're going to put 1 in front of the bigger one. There's 1 kilometer. Now in 1 kilometer, how many meters are there? Well, we know that there are 1,000 meters in a kilometer. So now here, we canceled out our kilometers and we have meters, which is what we want to have, right? That's what we wanted to have. So we're done with that one. Now we want to get rid of the hours. So if I had hours in the denominator, I need to put it in the numerator. Okay. So if I have hours up there, I want to get it to seconds. Okay. Well, which one's bigger, an hour or a second? And obviously that is 1 hour. All right, so how many seconds are in 1 hour? That's what we have to calculate. Well, we know that there are 60 minutes in an hour and there's 60 seconds in a minute. So that's going to be 60 times 60, which is 3,600. And now my hours cancel out and I end up with meters and seconds. That's exactly what we want. So now what we do is we multiply the numerator straight across. 90 times 1,000 is 90,000. And then we have 3,600. And my units, like we said, are meters per second. However, what we need to do now is simplify this. So we're going to take 90,000 divided by 3,600. And we're going to end up with about 25 meters per second. And there's your answer. All right, example 6. We're going to calculate driving distances. From Minneapolis to Winnipeg is about 450 miles. Driving distance between Vancouver and Seattle is about 325 kilometers. We want to convert 1 from miles to kilometers, that's A, and we want to convert number 2 or B from kilometers to miles. So it says A, convert the distance from Minneapolis to Winnipeg to kilometers. So we say that it's 450 miles. Okay, and we're going to call that over 1. Just there's nothing in the denominator. We can write it as a fraction over 1. Now again, I want to get rid of the miles, so that goes in the bottom. I want to convert it to kilometers, and that goes on the top. Now, which one is bigger, a mile or a kilometer? And that is a mile. Now, we need to find the conversion for how many kilometers are in the mile. You can do this a bunch of different ways. It's actually in your book on example 6 out of the book, or you can Google it or whatever you need to do. But the conversion is, it's 1.61. Okay, so there's 1.61 kilometers in a mile. So now, again, the miles cancel out. We take 450 times 1.61, and we want to convert it to the nearest kilometer. So it's about 725. So approximately 725 kilometers. Then we're going to convert the distance from Vancouver to Seattle to miles. So it is 325 kilometers. And now we want to calculate that into miles. So if I have kilometers in the numerator, kilometers in the denominator, then I'm going to put my miles in the numerator. Again, we know that a mile is bigger. And again, we know that the conversion now is 1.61. So the kilometers cancel out. And we take 325 divided by 1.61. And that gives us approximately 202 miles. Now notice here, if you see the squiggly lines for your equal, anytime that we do an approximation or we round it off, we should put that instead of an equal sign because it's an approximation. All right, so that is example 6. Now, the rest of these problems, guide to practice. Go ahead and take a couple of minutes to do questions 9 through 14. I will pause the video and you can hit play when you're ready to check your answers. And here are the answers to your guided practice questions. So number 9 was $11.50 per hour. Number 10, it took 4.5 hours. Number 11 was 37.3 miles per hour, about 12, we got to about 450 feet. 13 was 32 pints, there's 8 pints in a gallon. And number 14, if you notice, we had to convert years all the way to seconds. So the way that I did it is I knew there's 365 days in a year. Then in a day, I knew there's 24 hours. And then in an hour, I knew there's 3,600 seconds. So we get 504,576,000 seconds in one day. Now notice in all of these problems up here, I wrote them in a complete sentence. If you have a word problem, I would like you to write those in complete sentences. We'll talk more about that as we go on. So here is the suggested homework assignment for section 1.1. Begins on page 6.